Hello, good day, and my name is Favor Ulumesi, and today we will be talking about binary search. Binary search. Now, imagine you have a list of numbers. Let's say 1, 23, 45, 72, 89, 91, and let's say 102. And as you can see from here, all these numbers are sorted in order. Now imagine we want our target to be something like target equals to 89. Definitely we could use a for loop to achieve this, to find the position of 89. So we could do something like for I in range, let's say len of norms. So we say if norms I is equivalent to the target. Okay, what do? We'll print the index, then we can break out of this code, right? So let's run this. So it gives us 4, which is 0, 1, 2, 3, and 4. Very correct. If I change this to 91, you'll see now it gives us 5. But now the problem with this is that a for loop makes use of O of n complexity. O of n complexity. So this is a problem in a situation whereby we have a whole lot of elements or items, list items. So we could use a different algorithm which is called the binary search. Now what is the binary search? For the binary search, what we'll do is we'll make 2 pointers, one starting at the beginning, so that is the first index. I call the first index L, and I'll call the second index, that is the last index, which is from 0, 1, 2, 3, 4, 5, and 6. So that will be len norms minus 1. Okay, the y l less than r. So the good thing about binary search is that it makes use of O of log n time complexity. So it's much faster than the previous iteration we did. We'll create a midpoint. The thing about this is we have gotten 2 pointers, one at the beginning, one at the end. So we will now create a midpoint, which is the summation of L and R, and a floor divided by 2. Okay, so when we do that, we will check if the index aligns with the value of the target. So if it does not, okay, let's do that. So m equals to L plus R. Okay, so divided by 2, a floor division. So we can now say if norms are m, that means the number in the index of m is greater than the target. Let's say now the index falls here is greater than the target. What are we going to do? And our target, let me change our target back to 89. So our target is 89, the index falls on 91. So what are we going to do? So we will shift what? We will shift our L. We will shift our R to R equals to m minus 1. So if our index is greater than the index of the target we are looking for, we are going to shift our right pointer, I mean to say, to the index before m. Okay, but if it is less, elif norms m is less than target. So what are we going to do? It's less than target. We're going to shift our left index to the index after m. Elif norms of m equal to target. What are we going to have? We can say print what? Print m. Then we can also break out. So after we have done this, we will change the value of m. We will change the value of m once again. We will change the value of m once again. And after we have done this also, we'll change the value of m. Okay, so let's run this. Alright. So what did we do here now? It's first of all, we have a while loop. We created the left pointer and the right pointer. So we created a while loop whereby the left pointer should always be less than the right pointer, and it's going to break out when the left pointer becomes what? Equal to or greater than the right pointer. Okay. So now when we look at it, first of all we create the midpoint. The midpoint is the summation of both pointers divided by 2. So if the number is greater than the target, we are going to increase. If the number is greater than the target, we are going to shift the right pointer to the index before m. If the number at the index of m is less than the target, we shift the left pointer to the index after m. Alright, so let's solve some questions. So we'll start with binary search. So we say, given an array of integers, norms, which is sorted in ascending order, and an integer target, write a function to search target in norms. If target exists, then return its index, otherwise return what? -1. So we see here now, we have -1, 0, 3, 5, 9. The index of 9 is what? 4. Also, we now see a situation whereby we are told to look for 2, but there's no 2 here, so we have to return what? -1. So let's change this to Python 3. Oh, yes, Python 3. So let's implement this. So first of all, we'll create the left pointer, that's L equals to 0. Then we'll create the right pointer, which will be R equals to len of norms -1. Then we can now say I of the midpoint equals to L plus R divided by 2. We can see y L is less than what? R. What are we going to have? Y L is less than R. When I say L equals to m plus 1, then we change the value of m once again. Oh, sorry, I made a mistake. So we say if norms m is less than what? Than our target. If norms m is less than our target, the left pointer will be m plus what? Plus 1. We shift the left pointer to the index after m. Okay, and we now say else if norms m is greater than the target, what are we going to do? We shift the right pointer. Okay. now say if m, or rather if norms m, sorry, is equal to the target, what are we going to do? We're going to return what? We're going to return m. But in a situation whereby we don't get the value, then we'll now return what? -1. So let's run this. It's taking more time than expected. Oh, I made a mistake here. So let's run it again. Okay, so let's submit. Okay, there's wrong answer somewhere. Okay, let's see. So let's do something. We have an error here. So how can we solve this? So the problem was that it expected 0 because of course it appeared at index 0, but yet it gave us -1, stating that it did not find it. So what could be our problem? Let's put this inside first. Let's put this inside and let's give it a go again. Let's run it first. Okay, let's submit it now. So it's still wrong answer. So Z. So let's say R plus 1. So let's run it again. And let's submit. Okay, so we are good. Alright, let's go to the next question. So now we have search insert position. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it will be found if it were inserted in order. So in the example code, we can see that the index where 5 is 2. Now we don't have any 2 here, but the index could have appeared would be 1, that is 0, 1, where 3 is right now. The index of 7 does not have an index right now, but where it should have appeared would have been 0, 1, 2, 3, and 4. Are we together? Okay, so let's give this a go. So we are still using our binary search, definitely. Using our binary search. So let's say len equals to 0. And when I say r equals to length of norm -1. So we say y l is less than what? R. Y l is less than R. Okay. So y l is less than R. What do we do? Y l is less than R. We create our midpoint equals to L plus R over 2. Then what do we do? So we say if norms of m is greater than what target? What's next? L equals to m oh sorry, r equals to m minus 1 elif nums m is less than target. Okay, when I say L equals to m plus 1, okay, then we can now go forward and say else. That means if the value we get there is the value we are meant to get, we say return. So we say else return m. That means at the point whereby the nums m is equals to the target value, right? Okay. Now what about the situation whereby we don't find m? What do we do? If there's a situation whereby we don't find m, so we can just say else what are we doing? Sorry, that's a mistake. I will say return what? Return L. That means the left pointer. Okay, so let's run this. So now there's an issue here. And what's the issue? We expected to get 1 here, but it gave us 0. Okay, let's also check the issue here. We expected to get 4 here, but we got 3. So we can do something. We can say if what? If the target is what? Is greater than nums L, return L plus 1. Okay, so let's try it again. Okay, so we submit. Okay, alright, thank you so much. That will be all for today. Thank you.